Here we are back with part 3 of the summer packet video. Question 11, where we are sketching and showing important features like mins, maxes, intercepts, asymptotes, and endpoints. So here we have a linear function. So let's see if we can cram all these onto this page here. I'm going to do some freehand axes here to take up less space. I would hope you guys are using graph paper on a separate sheet of paper or something. So intercept is 2, slope is 3, rise 1, 2, 3, and run 1, 2. So here is the graph of A. No minimum, no maximum. Intercept we showed right there at 0, positive 2. No asymptotes, no endpoints. Arrows indicate it goes on forever. Part B is now a quadratic. It is a positive quadratic, so it opens up. But it has an intercept down here at negative 3. Let me get my x and y axes labeled, x and y. As we mentioned right here at negative 3. Okay, so that would be a minimum value right there. Let's put in a 0. We already got negative 3. Put in a 1, we get 2 minus 3, we get negative 1. If we put in negative 1, we'll also get negative 1. So there is our graph. This was a minimum as well as a y-intercept. We have the x-intercept right here. If we set this equal to 0, right, add 3, divide by 2, and take a square root, we get plus and minus the square root of 3 halves for x. So we've shown intercepts, x and y intercepts. There are no endpoints, no asymptotes. The minimum is the vertex, and there's no maximum in this case. Part C says feel free to use your calculator for part C only. I've already entered the equation into my calculator. Here's what the graph looks like. I don't particularly like the window, so I'm going to change the window from negative 10 to 10 to negative 5 to 5. Look at the graph now. And there it comes in. Alright, so I'm going to take that graph, plop it on here, and let's make it a little smaller. There we go. There's no min, no max. It looks like we have an intercept here at negative 1. Right, y-intercept at negative 1. X-intercept, we got to play around that for a little bit and try to solve this guy equal to 0, or since we're allowed to use a calculator, let's see where my calculator is, right here. We can do second calc. We're looking for the 0. Here's my cursor. The 0 occurs between left endpoint. Whoops, way too far there. I was expecting that line to follow me. And between the right endpoint, there it is. It occurs in there. I'll guess somewhere between there. So right there at 1.318, we'll call it. .381, if I remember correctly. 1.318. 1.318, and that was a 2. Alright. Let's look at number. Yeah, letter D. Square root of x minus 2. So, square root of x minus 2. If you forget what the minus 2 does, you can always just plug numbers in. If you plug a 2 in, you get 0. If you plug a 3 in, you get square root of 1, which is 1. Okay, so that square root of that minus 2 actually shifts everything to the right 2 units. It has a nice little square root graph. And E, this should have been the most recent course for you guys there, trig. So the sine graph normally starts at 0. Well, this says add 1 to it. So I'm going to start up here. And this is our sinusoidal coming across here. Right, we have our x and our y, or our k of x graph. So I'm going to start there, and I'm going to go between 0 and 2. Okay, and of course that goes on forever in that direction. And in that direction. So there's our graph for number 11. Let's flip the page, next page, and start looking at some of these guys. So we're looking for answers in degrees. So where is the y value? -1/2. Well, I'm going to draw out my unit circle. The y value takes on a value of half here at 30 degrees, so it's -1/2 at -30. And also in the third quadrant at -150. Cosine takes on values of a half. Well, cosine is my x. That happens up here at 60 degrees. Right? So where is it? -1/2. That's the second and third quadrant. So 60 degrees away from -180 is -120. Whoops, I'm going in the wrong direction to get between 0 and 360 here. Let me digress a little bit here. Those are values, but we are looking for the counterclockwise direction, right? The positive way. So let's go back to this one. 30 degrees, so we're looking at 150. Nope, positive there. So 210 and 330. 30-degree reference angles. This one we said was 60-degree reference angles, so we're looking at 120. And x is also negative in the third quadrant, so 240. 60 past 180. 60 before and 60 past 180. This was 30 after 180 and 30 before 360. We're going to solve this one. So the first thing I'm going to do is take a cubed root. Well, think about it like this. 81 equals the cubed root of b to the 4th power. Alright, so if I cube both sides, 81 is going to be huge. I don't know what 81 cubed is, but if I take the 4th root of both sides, the 4th root of 81 will equal the cubed root of b. Well, the 4th root of 81, 3, 9, 27, 81, is 3. So 3 equals the cubed root of b, and if I cube both sides, I get 27. Alright, so make the number smaller before you try to make it bigger. Then we got this one here, so we can rewrite this as 5 to the x equals, excuse me, 25 to the 1/4. And better yet, 5 to the x equals, well, 25 is 5 squared to the 4th, and better yet, 5 to the x, power to power we multiply, 2/4 is a half, so x is 1/2. Okay, not ideal. Ideally we solve math problems working down, kind of forced to go across here with the limited space we have, so we use these arrows showing the direction we go as opposed to an equal sign. 15, solve the following. Well, we're going to use our properties of logs here. So when I'm adding between common logs, both with base 2, we can switch that into a multiplication problem. So I have log base 2 of 5 times x plus 2 equals 4. And now I can say 2 to the 4th equals 5x plus 10. So 16 equals 5x plus 10, which means 6 equals 5x, which means x is 6 over 5. That was A. B, 4 to the x minus 2 equals 1/32 to the 2x plus 3. I'm actually just going to rewrite that one here to start. 1/32, 2x plus 3. So we have to figure out what 4 and 32 have in common. They can both be written as forms of 2. There's 4. And 32, 1/32 rather, is 2 to the negative 5. So this becomes 2 to the 2x minus 4. This becomes 2 to the negative 10x minus 15. So now 2 to some power equals 2 to some power. Well, we know those sum powers must be the same. 2x minus 4 equals negative 10x minus 15. Add 10x, we get 12x. Add 4, we get negative 11. So x is negative 11 over 12. And that was B. On to number 16. Same idea here as we just did with B. 10 to the 2x plus 4 equals, I'm going to write this as 10 to the negative 2. And then x minus 3 it looks like. So 10 to the 2x plus 4 equals 10 to the negative 2x plus 6. So 2x plus 4 must equal negative 2x plus 6. Add 2x, I get 4x. Subtract 4, I get 2. So that tells us that x equals 2/4 or a half. Oops, notice some disappearing stuff going on there. That happened quite a bit last year. We'll see if bring it back. I think if I go forward and then backward, it jumps back out here then. Yep, did not disappear anymore. I think at this point we will wrap this video up and finish it with the next video. See you in a bit.